Chapter 11, Section 7. We're just doing a quick recap for the at-home audience. We're going to graph rational functions. A learning objective is to graph rational functions. If the learning objective has graph in it, our notes should have a graph in it. Thank you. Inverse variations are rational functions, which is just a polynomial over a polynomial. We need to find where our polynomial function is undefined. Anywhere where the denominator is equal to 0 is an excluded value. Can't have excluded values. No denominators equal to 0. Zombie apocalypse. Running, sweaty, terrible, getting eaten by zombies. No denominators equal to 0. So when I'm looking for an excluded value, I want to know when my denominator equals 0. So if I want to solve an equation for that, especially if it's morning and my brain is not firing on all cylinders, all we have to do is subtract 7 from both sides, and we get x equals -7 is our excluded value. All right, so we're going to use our excluded values to help us graph. A line is an asymptote of a graph if the graph gets closer to the line as x or y gets larger than absolute value. Okay, so let's see what that looks like. What is the vertical asymptote of y equals 5 over x plus 2 and graph the function? We're going to do this very same problem right at the bottom. Okay, so the first thing we do is find the excluded value. We cannot equal, x plus 2 cannot equal 0. So x equals -2 is our excluded value. It is also our vertical asymptote. Remember, when we have x equals a number, it gives us a straight up and down line. That straight up and down line, our graph is going to get close to, but it's not going to touch that line. It's going to go zoom up towards infinity and zoom down towards infinity as we get close to that line. So what you want to do is you want to make a little xy table. You want values that are a couple values before before -2, and a couple of values after -2. So if that way, that's what's called figuring out the behavior of the line. What's Milan doing? And then once we know the behavior, we can graph it. So when we plug in -7, we get out -1. And then we put that on our graph. -7, -1. It's right here. When we plug in -4, we get out -2.5. And when we plug in -3, as we get closer to that -2, x equals -2, we get -5. So as you can see, our vertical asymptote, we're going to get real close to it but not achieve it. And then we have to see, what does our function do? It could possibly come this way and merge out of negative land and come up towards positive land. So it's important we know what happens on the other side. So when x is equal to -1, y is equal to 5. When x is equal to 0, y is 2.5. When x is equal to 3, y is 1. So it does make that. Remember, we got our diagonal U shapes. An inverse function is that diagonal U shape. All right, so let's try that on our graph here. Let's make a little XY table. I actually like vertical XY tables. It's just what I do, vertically. The one above is horizontal. All right, so we need to identify the asymptote. So I'm going to take that denominator, set it equal to 0. What's the end game? X is equal to what?
6.
6. And we get that by mathematically adding 6 to both sides. So I want to know a couple numbers before and a couple numbers after 6. So let's go 0, 1, 2, 3, and let's do 7, 8, 9. Just for fun. Just kidding, not for fun, for work. Okay, so I'm going to take 0 and plug it in for x. I get, if you are not great at calculating numbers, that's not what you do like in your spare time like me, definitely feel free to pull up your calculator and do it on your calculator. So you guys have -3 divided by 0 minus 6. And you get 0.5. You can definitely do it on your calculator. Then you got -3 divided by 1 minus 6. I put parentheses because it's the denominator and I don't want it to accidentally divide by 1 before it minuses the 6. Thank you, order of operations, for teaching me that. -3 divided by 2 minus 6, I'm pretty sure will give me 0.75. -3 divided by 3 minus 6 gives us 1. So if I am graphing these, let's graph these points so we can see where our behavior is. On this graph, if you look, my x values kind of positive here. So I'm going to start my x-axis more here. So my vertical asymptote, I'm putting that in there. So get your highlighter out. We'll make a nice dashed line at 1, 2, 3, 4, 5, 6. So we're going to put a dashed line at x equals 6 because we know cannot touch this. Thank you, MC Hammer. Can't touch that line. We cannot get anywhere near this line. So grab your highlighter, make sure that's highlighted. Cannot touch this asymptote. Okay. So let's put some plots down here. I'll do pink plots. So we've got 0.5. We've got 1 and 0.6. We've got 2 and 0.75. Man, this is a slow moving train right here. And we have 3 and 1. So as you can see, we're increasing. So when we get, because we're increasing as we get near x equals 6, we want to shoot that up to infinity. So that's our U shape, diagonal U shape. Let's plug in 7 and see where that gets us. -3 divided by 7 minus 6. Actually, no, this one. This is -3. 8 minus 6 is negative, I'm sorry, yeah, negative 1.5. -3 divided by 8 minus 6 is -3 divided by 2, which is negative 1.5. Last but not least, we got -3 divided by 9 minus 6. So -3 divided by 3, which is -1. Let's plot these points. I'm going to guess it's going to be down here. But let's plot and see where that takes us. So at 7, so here's 6. At 7, we're at -3. I'll make it a big dot. At 8, we're at -1.5. At 9, we're at -1. So if you look, this goes that way, and it comes down and gets close to y equals 0. You can use Desmos to check your work. So our equation is -3 over x minus 6. So we can go to what I like to call the internet. I made it up. I'm just kidding, I didn't make up the internet. I love Desmos.com/calculator. I like it more than my graphing calculator, which is saying a lot. So we got y equals -3 divided by x, was it -6? Yeah. So when we look at our graph, we know it crosses at 0. So let's look at the graph we made. Phew, and make sure it matches the graph we want. If you look at x equals 6, nothing. Because it's, what's that word? Starts with A. Asymptotes. So, anyway, you can use Desmos to check your work, and I encourage you. Alright, so, identifying asymptotes. If we have a rational function, some number a over x minus b plus some number c, the vertical asymptote is at x equals b, and guess what? The horizontal asymptote, what? Is at y equals c. Let's look at the Desmos again real quick. If you look here, it also doesn't touch the line y equals 0. It gets really close, but it never actually touches y equals 0. So y equals 0 is a horizontal asymptote. X equals 6 is our vertical asymptote. Awesome. And if you look at our equation, this is like having a +0 on the end. If there's nothing on the end, then our horizontal asymptote is y equals 0. So for example, they have, let's highlight our example. Y equals 1 over x plus 4 plus 1. So you always want to take the opposite of what's next to our x. So our vertical asymptote is x equals -4, and our horizontal asymptote is y equals 1. Let's do that on our own. What are the asymptotes of the graph? Y equals y equals -1 over x plus 3 minus 4. Graph the function. It is impossible for two different rational functions to have the same vertical and horizontal asymptotes, and explain your reasoning. Alright, so we want to identify what our vertical asymptote is here. So if I look, I have x minus 3. What can my denominator cannot equal? 0. So x equals -3 is my horizontal asymptote, or vertical asymptote. And whatever this value is here, that's our c value, that's our horizontal asymptote. So we are going to, I'm going to extend my page because I need more room. I got big handwriting. Make a little graph. Because doggone it, if your learning objective is to graph, we better be graphing. We want to go 1, 2, 3, and we want to go 1, 2, 3, 4. Let's put our dashed lines At x equals -3, because this is our asymptote, can't touch this, and y equals -4. So our graph is either going to go diagonal use this way, or it's going to go diagonal use this way. And it's really the A that tells you what it's going to do. If A is positive, then it'll go this way and this way. If A is negative, then it's the opposite. So in our problem, A is negative, so it's going to go ahya and ahya. So let's make just like a baby XY table. Let's do one number before our vertical, so that's -4, and just one number after. Let's go 0. So if I'm putting -4 into here, so it's -1 over -4 plus 3 minus 4. -4 plus 3 is -1. -1 divided by -1 is 1. 1 minus 4 is -3. I'm going to do the same thing, but I'm going to plug in 0. -1 over 0 plus 3 is 3. -1 over 3 is -1/3. Minus 4 is -4 and 1/3. Let me plot those. See what we got going on. So x is equal to -4. Y is -3. And here at 0, y is equal to -1. -4 and a third. All right, so we're going to have our little U shape. Go that way, and that way, and this one's going to go this way, and that way. Boom, graphed it. Now we're going to check it using the Asymptotes. -1 over x plus 3 minus 4. See if I can remember that. -1 over x plus 3 minus 4. Boop-a-doo. Look at your graphs. Does it match the graph that we drew? So once we can find the asymptotes, the rest of it is pretty easy. All right, last one. Right? Tell me this is the last one. No?
No.
Two more? Okay. So we need, where does this work in the real world? So we're going to go to a dance club. I'm going to say it's salsa dancing. Sponsors a contest at a local reception hall. Reserving a private room costs $350, and the cost will be divided equally among the people who enter the contest. Each person also pays a $30 entry fee. We're going to write a little equation. Now, the reason I put this in your notes is because they're going to give you a problem that's pretty similar to this, and we have to know how to put it together. What equation gives the total cost per person, y, of entering the contest as a function of the number of people, x, who enter the contest? So the total cost of the person is equal to cost of renting a private room divided by the number of people, because you got to split it amongst all those guys that come, plus the $30 entry fee. So we have a nice little equation, 350 over x plus 30. What is the graph of the function in part A? Awesome, we'll just put that in our graphing calculator, right? Easy. Not asking the world. Since both x and y must be non-negative numbers, use only the part of the graph in the first quadrant. Does it make sense to have negative money when you're trying to find the total cost per person? Man. Nor does it make sense to have negative people. So anything negative negative people aren't allowed at salsa dancing contests. Approximately how many people must enter the contest in order for the total cost per person to be about 50? So here, if you have a graphing calculator, you go to the trace or the table feature. I'm going to show you how to do this on Desmos. So let's put this 350 over x plus 30. $350 over x plus 30. And what I do is I just put, if it says, what is it at 50? I just put y equals 50. Because it makes a line, and where they cross, it'll give you a nice little point. So I need 17 and a half people to make 50 bucks. It'll be $50 cost per person. So if you have 17 and a half people. Or approximately 18, because you can't have a half person. Crazy, not a half person. All right, so let's apply this on our own. In problem 4, suppose the cost to rent a private room increases to $400. Approximately how many people must enter the contest in order for the total cost per person to be about 50? So we're going to change our equation. So let's write that down. We're going to change our equation. Instead of 350, we're going to have 400. And then when we do that on our graphing calculator, we just change this value to 400. And it is 20. So at x equals 20, the total cost will be $50. All right, lastly but not leastly, I wanted to put in your notes this families of functions. I wanted you to have the linear, quadratic, absolute, exponential. We've done all these functions. We recently did square root, and lastly but not leastly, rational functions. That way nobody can say you never saw this.